Hello, my name is Ebony Drysdale Daly, and today I'll be talking to you about biomechanics and psychology in sport. First of all, momentum. Momentum's definition is the amount of motion in a moving body possesses. So, a simple equation, as you can see on the screen, momentum equals mass times velocity. Mass is measured in kilograms and velocity is measured in meters per second. The simple sign for this is m/s, and a simple equation that you can get from the example where it says momentum of a 5 kilogram object with a velocity of 2 is equal to 5 times the 2, and it equals the kilograms per meters per second. Another simple equation could be momentum divided over mass times velocity. If you click onto the link below, you can then go and see a simple little explanation further where you can then click on it to see the icon move. A quick fact on momentum is that momentum is said to be conserved on the principle that neither mass or velocity is affected when momentum is in action. Projectile motion. Projectile motion, the release of motions are that sorts of events in the concept of flight. So there's several factors that are in this: the release of a projectile, the influence, and the flight path followed by the projectile. Angles of release, and the velocity at the moment of release, and the height of release. So as you can see, the simple image, when it changes from a more detailed picture, it shows that the arrows give a more brief example to how much pressure each factor has on the projectile and the motion. So the vertical, velocity, horizontal, and gravity. Moving on. Further, projectiles in motion can be other factors as discussed previous. Pushing an object determines the direction and rotation of flight. Force of gravity has a downward effect of flight. So as soon as there's contact with a driving force, like for example a thrower has been typed, as speed increases, air resistance has a greater retarding effect on an object. So this ultimately will slow it down and is a big factor. And also the impact on height and distance. So athletes, a jumper, or training to build power fitness, they will do other combinations of speed and strength to improve their jumping time in air, and that's all to do with projectiles in motion. Moving on, as a quick little description further of what you can put into account. The weight is always constant, and also the drag depends on the square of velocity, so the wind, the weight, and the height. And there again are simple equations if you're reading forces on a falling object. Now moving on to Newton's law of motion. Law of interior relates to this notion in that everybody at rest or moving with a constant velocity in a straight line will continue in the state unless compelled to change by external forces upon it. So you see the simple image, that's movement against gravity. Then moving on. Two forces are acting on this opponent, as you can see the rugby ball. So obviously the Earth's gravitational pull, and going through the centre of the mass of the ball, and also the actual thing holding it up, which is the T. So that has another force pushing up against it. So a ball will always remain motionless unless disturbed by another force. So an excellent example is the image that I've got there of a person kicking it. So therefore it would transfer action and force, causing it to overcome interior changes into a state of motion. Moving on, Newton's second law of acceleration. It says the law is quite summative to acceleration. Another object of the body or directly proportional force acting upon it. So in summary, that means to produce greater acceleration, an individual must generate proportionally greater forces. So as you can see for the image, a rugby person running up and then expelling higher force onto it to give it more velocity, for more acceleration. Newton's law of action and reaction. For a reaction, there is an equal and opposite reaction. So doing a high jump, jumping up, but you're still going to move down. There's the application of forces. Without force, we wouldn't be able to do many things. So jump, throw, kick, push, pull, all we take for granted. When force is applied to an object, the velocity of the object changes. So that creates an acceleration. A change in velocity effectively gives that change. And you can see these brief images: acceleration, deceleration, change in direction, change in shape. These are all such things that happen. Now moving on to lever systems. There are three that are quite summative to put into context. There's first class levers, which is the fulcrum, pivot point about which the lever rotates. There is second class levers, a load, the force applied by the lever system. And there is second class levers, which is fulcrum, the force applied by the user of the lever system. So it always has fulcrum, load and effort in each first class, second class and third class. As you can see, the examples are for first class, the head. You can see just where the force is, and it's mainly focused on the force of the input force for first class lever. For a second class lever, it's more focused on the output force. So you have the example of the heel. And for the third class lever, you have more on the diagonal balance of just how it works. So I've used an example for an elbow. The output force is used to lift your arm, and these are all examples of where these are featured, first, second and third. Moving on to examples of a little bit more of how they move in the human body, just a repetition to make it get through. As you can see, effort is being applied downwards to the biceps, making the fulcrum rise. That is, again, first class lever. Second class lever, movement that would replicate a standing heel raise. And third class lever, the most commonly used lever system within the body, bringing the effort upwards. Okay, reaction in forces. Balance forces, objects either stay in the same position or move at that constant speed. Occurs when two or more forces are in operation of equal size and equal direction. So you can see for these images, I've got a swimming one, there's an action force, and there's an equal reaction force where they are moving in constant same, so one cancels the other out. So, and as you can see, another image of acceleration and reaction. Horizontal components of the force in this image. Unbalanced forces, on the other hand, will occur. A force acting in one direction is larger than the acting in the opposite direction. So as you can see from the cricketer, his acceleration is a larger component towards the reaction of the rest of the forces going on, as the detail says. And then types of forces, there's vertical force. Weight force is equal to the product of mass in the body, acceleration and gravity. There is a simple equation, weight equals mass times acceleration due to gravity. Mass is not weight, a thing to alliterate. And Newton's second law can be written as examples of F equals ma. So F equals unbalanced force, m equals mass, and a equals acceleration. These are basic things to remember. Horizontal forces is friction recessive force encountered two or more bodies in contact to move past one another. So it's so for example, air resistance, a form of fluid friction. Therefore, opposite movements, the degree of resistance occurs on velocity of a moving object, frontal cross-section area of the body, and also other aerodynamics of moving objects. So impulse is another prominent to remember. Athletes can increase impulse by the amount of muscular force they apply. For example, the jumper would need a considerably lot more strategies to generate more to get a higher jump higher up in a competition. So when a force is applied to a body, resulting in the motion by dependent not only the magnitude applied to the force but also the duration of the force application. So a more definition is impulse is the product of force and time over which the force acts. And moving on to psychology in sport, there is a grey area of aggression and assertiveness. Aggression can be defined as hostility and emotion. It can be caused by multiple